Start recording now. Ooh, you were just right in time. Yes, of course. We're all waiting for you. Yeah, hi everybody. Yeah, almost in time. My name is Evgeny, and I will be your teacher in this course, in this study period. And so just again, to be sure that we are on the same page. So this is the course G0034E, Applied AI, Knowledge Management and Reasoning. And well, the goal with this lecture is really, well, this is really an introductory class. And I want to spend some time to recapitulate on the rules of the game, and also to kind of introduce myself to you. Well, I will know some of you through the interactions during the course, during this course and the course next year that you will take with me, which is the also called Applied AI, but it's an advanced level course focusing on learning. So I will tell you a little bit about my place in the AI landscape. So we will be talking about AI. So just to be sure again about understanding of or background of yours. So AI. So what kind of courses did you had before this class? Introduction, and is it one course or two? Two courses, okay.
Yeah, like programming and machine learning, and similar course which we use rapid mining.
Okay, so it's more on data mining, like visualization and stuff.
Yeah.
Data science, kind of. Okay. And machine learning, so what, just again, you see, I'm asking this because, I mean, you're already second batch of students in these new programs. And I'm a little bit unsure which courses, what kind of background you have. So machine learning course you mentioned, so what was it about? Like?
Supervised and supervised learning.
Okay. Okay, that we will also reiterate next year then, but in a kind of more in-depth manner. This study period we will be focusing on reasoning, knowledge representation and reasoning. And again, so before we go into the technical discussion about AI and stuff. So let me tell you about myself a little bit. Oh, that needs to be removed, I guess. So I will skip the animation. So this is my path to here, to the north. So I'm originally from Russia, from Krasnoyarsk, from Siberia. So very far away, cold place, but rather large city. And actually, I lived in quite many countries before ending up here. And that what you see here is probably a typical, career path of an international researcher, or a researcher who is interested in being international, actually changing places, changing topics, being curious about different stuff. So my background is from telecommunications and the internet, so the low-level protocols and such. So I did my PhD in mobile networks, mobile communications, and I am within the AI business. I'm since past maybe 15 years, and there is a great deal of explanation behind, or a great deal of reason behind this move. So when you do networking, so you work with communication channels, so you are about communicating information from one place to another. And at some point, I was interested in a technology that is currently known as the Internet of Things. You probably know. So it's, at that time when I was researching in this area, so it was called wireless sensor networks. So small devices, you know, processing, sampling the environment, and doing some processing to extract certain useful information out of raw data. So already now you can have an idea, or maybe have this picture of an agent being situated somewhere in the environment, having sensors through which it perceives the environment and do some computations. But then, of course, I mean, as soon as you work with this kind of technology, sooner or later you understand. And again, so my focus was on the communication part. And then you understand that the bottleneck is really the amount of information that you want to transmit. And transmitting information is a very, very costly business. So basically transmitting a bit of information is equivalent to processing of, well, hundreds of hundredfolds of bits. So I started to look at some computational issues, and then actually, I mean, without any connection to AI or not having AI in mind, but then and then I was I found one interesting computing framework and computing theory that I'm currently active now. And it happened to be that it is very, very tightly connected to artificial intelligence. And I will show you in what way it is connected. And as I said, so I'm doing my research in artificial intelligence since past 15 years. And actually, even first courses in this department about AI was also developed by me. This is rather new course, so it's a second occasion I give it. So, and before that, I was involved in teaching in many other courses. So now I'm actually focusing on only 3. So again, same people from the same programs. So now they take computer network security, and then they meet me in this class. So year after. So that's all these 3 courses that I'm teaching now. They are kind of dedicated to your programs. And then we have Oliver here. So it's part of the team. Yes. So maybe you can say a couple of words. Can you say a couple of words about yourself?
Well, yeah, I'm a previous student. I'm still a student actually in the 3rd year of the master's program of what's called applied AI thing. So I'm just 1 year ahead of some of you second years. So I previously went to this course, which is why I'm a TA for it.
Mm-hmm. Yes. So Oliver will be assisting you with practical questions regarding labs. But actually, well, as I will comment very, very soon, his role until very, very last moment when his intervention is really needed will be rather observational. So it is expected that you will help each other in this course by means of participating in discussions online. Yes, and as I said, so the agenda for today is not very ambitious. So we will be I will recapitulate the most important rules which must be said, and give you an opportunity to ask some questions. Otherwise, they are all summarized in Canvas room. You probably have visited it. Also, again, just an acknowledgement. I'm grateful to my colleague and friend from Jyväskylä University who shared with me some of the materials that I'm using in this course, as his group is focusing on representation of knowledge in the practical context. Course material. So the course book is AI: A Modern Approach by Russell and Norvig. And I have updated Canvas README page. So I removed the reference to a specific version, well, to this one. And basically, since as I understood already from some messages from you that it is outdated and it's kind of expensive, so there are new versions. That's fine. So you can use whatever book you have. I think there are no major changes in the chapters. If you are not sure, then about
yeah, I can add to that. The chapter numbers are a bit different, but the chapter names will be essentially the same. I have the 4th edition, so I can send out the titles and pictures for those.
Great. Yes. Yes. Canvas. So all the information is there. It's already published to a large extent. So all video recordings will appear by the end of each class as YouTube recordings. So you will have a link. So PowerPoint slides will be also available as PDFs for your consideration. And there will be also in this for the second part of the course concerning ontologies, there will be also digital resources available supporting the lectures, the classroom lectures. Here is the content, or maybe let me see. Let me switch to this graphical representation over here. So thematically, so this course contains of 2 parts. First of all, so this course is a basic level course. So it's supposed to give you an overview of some of main technologies, and as such, so it is like it is. So it will provide you an overview of logical agents and propositional logic, and where you will, well, it's one of the simplest logic. You probably have worked with it in your earlier years. If you did, then again, so you will renew your knowledge. And here, so you will work with propositional logic in the context of AI. So, I mean, again, propositional logic can be taught in different contexts. And you will also work on lab 1, implementing a logical agent. So that will be your programming assignment. The second half of the course, or the second part, it's not a half, but the second part of the course is dedicated to a technology called semantic web and ontologies. And again, so the choice of this technology is twofold. First of all, semantic web is something that is not fully kind of developed yet, but so it serves as a really good playground for showing the concepts, and and also the way how ontologies are used to describe practical scenarios and enable reasoning. So, and I hope that when being exposed to this classical way of reasoning via logic and ontologies and operating using different kind of reasoning agents, you will make certain links and connections in your mind about open issues. Then, so you should expect a couple of guest lectures towards the end of the course. So this year, I decided to invite a professor working with embedded systems, so programming, software development for embedded systems. And he will be talking about, well, an application of SAT satisfiability solvers to program verifications. So again, so SAT solvers are used in the logic context. So when you have a knowledge base, you have set of rules, you have predicates, and your reasoning is about finding satisfiability of this predicates to the knowledge. And then, so the SAT solvers help you with that. But again, so here you will see that these techniques, which were developed as part of AI agenda, they are heavily used in, well, maybe not directly related to AI areas, such as software engineering, for example. Yes, and finally, I hope, so if nothing unpredictable will happen, there will be a guest class given by a Ukrainian professor who is part of my group here on similarity-based reasoning. So, and again, so that's that would be interesting link to learning. So really representational learning. So we will discuss this problematic soon. Yes, as for the course moments, so you will have classes with me. So they, I mean, for you campus students, so they always will be here on campus. I checked, so the rooms will be somewhat more appropriate or pleasant, so to say, further on. But since we have a large group of students sitting online, so so all lectures will be recorded in Zoom and be available offline, of course. We have, as I mentioned, 2 labs in this course. So one lab dedicated to logical agents and propositional logic, and the second lab to semantic web. So you've or an ontologist. So lab 1 is maybe a bit more difficult. So with respect to time, so complexity is higher. And so it generates more points this year. So it's, I mean, I changed the point settings compared to the last year. Then you have home assignment, where you need to review some chapters of the book. So so that would, to me, this is a kind of insurance that you at least read certain chapters and try to follow the agenda there. And plus you will review one research article and summarize it. Finally, you will have 2 online quizzes. So again, so there is a change compared to the last year. So last year, campus students had quizzes in real life, so to say, so sitting in a booked class. This while so the distance students, they had a more flexible scheme. So I decided, so I did some evaluation. So I was quite happy with how it went in that flexible manner. So this year, so both groups of students will have totally flexible quiz times. So the days for the quiz will be announced very soon. So on the date of the quiz, so you will see an assignment appear in Canvas. And as soon as you start it, so this is a quiz, like a test. And as soon as you start a quiz, so you will be given some total time to complete. And as you when you complete, so and you're given one attempt to do so. All communications within this course happen in Discord. And this is the major change, kind of functional change in the, or administrative change in the in this course compared to the last year. And so after many years of students complaining about Microsoft Teams, I don't know, to me functionally it's all the same, but I decided to upgrade to Discord. So here we have Discord. I hope you're happy with this. And I see many of you have already subscribed to the server. So is there anybody who didn't subscribe for the server in this class? So you should. And now just to show why am I saying that this is the main channel. So I discourage you by all possible means to send me an email. It simply doesn't work. Why? Look at this. So this is my mailbox. No, seriously, look at this number. So this one, 20,000 unread emails. So the long story short, I mean, once upon a time, like long time ago, I went one or maybe even two courses on efficiency at work. You know, we had a special dude teaching how to sort emails, you know, spending time and stuff. But then I discovered that the search engine actually is so good that, I mean, I don't need time to do this kind of job myself. So and since I don't know, past, I'm sure, well, I think the last time what I do instead, so basically after some time, so when the quota is overflown, they never can deny me increasing the flow. So this is the advantage of being professor here. So I moved the content to a special box like 2016. So that's the number I accumulated since 2016, I guess. But okay, the long story short, emails are a very inefficient way of communicating to me. However, these tools, well, if before this year it was Teams, now it's Discord. Here it works very well. So I mean, I answer well. What you can expect from me is that I will reply timely on your request. So you can send me PMs, you can send me or you can communicate in given topics. Oh, sorry, that's the wrong one. So I normally when I have time, so I just reply. So even outside working hours.
Kristen,
Yes.
how do you find this room? Like, is there some code or
For
the
Canvas. In Canvas, so look here. So you go to modules, and so there is a big there is separate module, the main communication channel. You click on this link and you subscribe to the server. And so that's why I'm saying that the role of Oliver to a large extent will be observational. believe me, I mean, so I started to practice this way of organizing communication in courses, well, obviously during COVID times. And it's already, what, 4 years, time flies. When I have it with some modifications, and it works perfectly. So I encourage you to say whenever you have a question, like technical question about the lab, so you get stuck on implementation of a function, so you don't understand something, so you post a question here. So for example, in lab 1, all questions concerning to lab 1, and then so you others who already figured out how to do that, I encourage you to help out others. And how do I encourage? It's not only saying that I'm encouraging you, I will give extra points. So I call it like a good fella point. And it works perfectly. So, I mean, this course is not very programming heavy, but for example, in the other course about computer security, so there are students with different backgrounds and some different, you know, pace of working. Some of them, you know, figure out how to solve certain issue faster or not. That's fine. But you know, answering questions, so it helps even other students to progress. And of course, there are situations when, like, the discussion stuck. And in this case, Oliver and/or I will intervene. So in the first place, you submit your problem ticket to Discord, and those of you who know how to resolve it, so you reply. So again, maybe I can show you a typical communication thread in my security course. So it's like very technical discussion. So sometimes the issues are can be very complex. Screen dumps, pieces of code. So and then so eventually, basically, within few hours, normally the problem is resolved. And then you would wonder. So actually, I mean, it just came to my mind. So it's like, what is then the role of instructor in this course? The role of instructor is really to enable this thing. So if you think about it, and actually I have a slide towards the end of today's presentation. So the paradigm of learning is changing now. So we are getting getting knowledge in a different way. So not just one way stream of you know, facts from instructor to students, but rather in an interaction way. So sometimes, and again, the role of of the instructor is to follow the discussion and see whether it takes correct or incorrect direction, for example. But otherwise, so the knowledge is already out there. So it's just a matter of enabling the communication and enabling the answering, the asking answering interaction. Okay, so let me see. The labs are peer reviewed, so that worked last year. So it will continue as a peer review even this year. So this means that by the deadline by the submission deadline, so which is indicated already in Canvas, you will be assigned one or two peers, so labs to review. And then, so you need to basically read the report or what the submission, read the submission and complete a Google form. So the Google form will be available soon. So the link, I will publish the link soon. So the deadline for the first lab is yet to come in December. And I expect that the review is submitted to Google Forms within 2 days after the deadline. So yeah, if you by some reason after the deadline is not you are not assigned a paper, so you should contact us. Yeah, so this is the gradient rules again, so they are summarized in Canvas. And again, so all everything that I have said is presented in the study guide. So this is the front page in Canvas. Any questions, like immediate questions?
I have a quick one.
Yeah.
It says midterm 1 and midterm 2 for those quizzes.
Yes.
Okay.
Yes. So what is not yet published are the dates for the quizzes. But you should expect first quiz to take place by the end of November, and the second quiz before Christmas. Yes. And once again, so yes.
I might have a wrong schedule, like do are not out.
They should be removed. I sent a request. Yes. So the yeah. No, there won't be physical meeting for that one. So I mean, I submitted this schedule request in May, so when I didn't do the changes yet. But yes, so basically on the day of the quiz, so now I tend to think that most likely the first date will be on November 24th, something like that. So last week of November. And so the second quiz will be before Christmas, maybe around 15th of December or so. So not to stress you out for the Christmas itself. Okay, so if there are, so let me check if there are some questions in chat. Yeah. Please, in case I will have to jump out, please can some ask this question. Yeah, if you have to travel, yes, that's yes. First question, so regarding traveling. So obviously it's a Christmas time, and it's not a surprise that you are traveling. And as you have noticed, I mean, there are no course moments after Christmas, or basically around Christmas until the end of the course, which require your physical presence. However, so the deadlines exist, and they come during the first week of January, which is the official week of the course. So independently where you are, so I expect that you find time to meet these deadlines. So and again, so that's the cost of flexibility. So you can be anywhere, but you meet the deadlines. If you don't have Wi-Fi, you for sure, I mean, we live in 21st century. Unless you travel to some very obscure places, you have 4 or 5G networks. Even there, in the obscure places, you have something normal. Starlink. Ask Elon Musk. Labs. Yes, labs are individual. Yes, and the assessment is also, the peer review is also individual. So everything is individual. Okay. Let's maybe talk about AI. And again, so I structured the second part in a way that mainly as a discussion, or rather, touching upon some philosophical questions, but I try to converge to some really technical problem formulations that we will be talking about in this course. So we start with this question just to be on the same page. So when you hear AI, so now when you, after this many courses that you have passed, after all these articles that you have read in news and stuff, so AI, what is it for you? Just cut me some keywords for me.
Well, somehow AI, based on my knowledge, it's an attempt to replicate the human mind.
Replicate human mind. Okay. And again, what? Yes.
You can also do the Turing test.
Turing test. So something that passes Turing test. ChatGPT passes Turing test. Are we done?
No, I mean, there's more to it, like there's different subsections of AI.
That's good. So different subsections. What kind of subsections, areas of AI?
Like image recognition, robotics.
Okay. These are applications like image recognition. Text. Come on, generate some more terms. So when you hear artificial intelligence in, well, 2023, so what is it? Yes, please. Huh? Self-learning computers. Yes, self-learning computers. Okay. All right. Okay. But it's kind of, so from what I see, it's at least it's very heterogeneous, or it's a heterogeneous definition, and it's a complex business, this AI. And obviously, the whole idea is to really to, I mean, the starting point was an ambition of humans to really replicate human mind. And these ambitions dates way back to in history than even middle of 20th century. Well, I will not go that far, obviously, but I mean, if you read all this, fairy tales and episodes, so people always wanted to, give intelligence to some artificially created entities. Like, you make something out of clay, and you want to make it, thinking creature. So in many cases, it turned evil. I mean, this kind of attempts, but very few attempts of being positive. With positive examples. Maybe Pinocchio is one. Very, very positive, but not very successful. Right, but let me go back to actually the definition. So we in this course in the other course of mine, we are talking about AI as it was defined in the middle of 20th century. So 1956. So there was a workshop including these individuals over there, Marvin Minsky, McCarthy, and such, who gathered in Dartmouth and actually coined the term AI, artificial intelligence. And so when thinking about AI, so again, so this picture you probably have seen many times, but this is the central abstraction. The central abstraction behind intelligent being or an agent. So agent as an abstraction of intelligent being. So and this agent, so its main property is that it's not an isolated entity or thing. It is placed in a certain context or environment. Environment is a generic term, so environment. It can be physical environment. It can be virtual environment. But this is something that exists independently of the agent itself. And when you place the agent in there, then it becomes, it needs to deal with this situation. So, and it deals with this situation in several ways. First of all, this agent needs to be able to discover this environment. And this is normally done via bidirectional communication channel. So sensor actuator links. So our sensors like vision, well, if we talk about humans, vision, taste, touch. So it's something that we can use to really start discovering the environment. But then also, I mean, the important part of this abstraction is that we can introduce changes to the environment. And again, observe the result of these changes through the sensor mechanism. And then there is a processing inside the agent that actually does something that at the end results in something what we call intelligence. So what are these properties? And again, so that's maybe it's kind of a little bit by the book, but it's I think it's a very important to keep in mind these properties and constantly think about it. Constantly think about complexity of each of these properties. So goal-oriented reflections on rich complex environment, operation on large amount of knowledge, usage of symbols and abstractions, flexibility as a function of the environment, learning from the environment and experience. So just to name them, but what is it actually? So that's what so understanding of these properties would lead to choosing one or another way for artificially recreating this capability. So goal orientation. So agents, or I mean, well, not agents. I mean, be as or any intelligent being doesn't act in an unrelated manner. So it is always driven by some desires or intentions. So there are some internal motivations that result in certain actions. And even when we try to achieve this these goals, so we do have orientation of this process of intelligent process, so call it thoughts. So because we are not trying all the variants. So already now, so it's I mean, you can see that even this property is has very complex functionality. Reflections on complex detailed environment. Again, so intuitively, it's very easy to understand. It is all about abstractions. So being able to abstract away, find details, and operate on higher level concepts and terms to again to solve certain tasks. And in our case, I mean, so well, humans for sure, but even animals, they have this kind of complex this kind of properties. So, but in our case, so even very high level sketch or verbal description of a location of something, so still is sufficient for you to kind of localize this place in an environment with very, very, very fine details. This is very interesting. Symbols and abstractions. So it continues kind of previous properties. So, and also with this property, you can probably link to the limitations of the current AI technologies. I mean, it's a challenge. It is still unsolved challenge how intelligent beings are able to learn abstractions from being exposed to very few examples of a phenomenon. So in the case of learning, so it is called one of few short learnings, learning techniques. But the important thing is that we operate on representations that are jointly referred to entire class of phenomena that we reason about. And moreover, we can these symbols, they are very complex in themselves. So they have this part-whole relationships, etc., etc. We will be talking about it. So how to enable this? So this is part of this is task of one of the tasks of artificial intelligence. Again, flexible behavior is function of the environment. Intuitively, again, so this is very understandable. So we are not kind of planning ahead all the way, like from and follow this plan from the beginning to the end. So our mental process is always modulated by changes in the environment. So we adapt our plans. So, and this is this should be part of the AI functionality. And again, so intelligent functionality is about being able to deal with extremely large amount of information or knowledge, actually. So there is the difference, obviously, between knowledge and information. But again, so intuitively, you can make this mental exercise, trying to describe in details assessment of a certain skill. So so then you kind of you can branch it down to very, very fine details. So this is very important. So we learn. So learning is a continuous process. So it's So we are not kind of born with all the skills. So we learn, we discover the world, and we learn these concepts as we go. But most importantly, so about this block. So it's not the property. The properties are important, of course, but it's this box inside the intelligent agent with the question mark that I showed previously. So the intelligent function. So the function that makes an agent intelligent. An intelligent function is a continuous process. So it's a non-stop process. So apparently, here is the algorithm. So it doesn't have end. So you take constantly input from the environment, you process it, you conceptualize it, you produce plans, you act, and then you start it over again. So that's kind of principle behind AI system. So talking about branches or sections of AI. So you previously you mentioned RAD applications like image processing and robotics and such. But if we go to the definition, so AI throughout the history put focus on different aspects of intelligence and recreating intelligent functionality. And the so the taxonomy is not very complex. There are basically two classes or two camps of AI researchers historically, those who believe that or those who try to model the knowledge by imitating representations of brain activities, and those who rely on who build logic on well understood rules. And this is important to remember. So this two groups, two branches of AI exist until now. They become more or less popular throughout the time. So I would say from the time when AI was coined until maybe very recently, end of 20th century. So symbolic AI was on the top. So and the neural chapter was less popular because of let's say very shy results at that time that they demonstrated on learning. So now the focus is changing. So now if you ask people on the street, so AI is about deep neural networks only, and so people even forget about this symbolic very important chapter of AI, which is symbolic. So on the level of definition, so the concept on the left, or the branch of AI on the left is called symbolic AI, as I said, also known as good old-fashioned AI. The concept on the right is also called connectionist approach. So did you hear this term, connectionists? So basically, it comes from the fact that they try to, I mean, the overall idea behind neural networks is that you can model higher level intelligence by training connections between neurons. So in this way, it is connection. And each and every individual neuron doesn't is not important. It is only an ensemble of neurons and their interconnections that play a role in modeling one or another concept. So, and in this way, and this is also, I think it's important to remember. So, symbolic, they also called localist. So localist versus connectionist approach. Localist meaning that symbols have unique meaning. So say words of a spoken language, of natural language, and specifically in textual forms. So we have our texts, they are purely symbolic. So they start with symbols corresponding to letters of the alphabet, and then we combine these letters to create new symbols which have different meaning. And then if you change something in the in this symbolic approach, in many cases it may change the representation of the high level symbols. While in the totally connectionist approach, changing the way how one or even a group of neurons is activated normally doesn't lead to a dramatic change of meaning or dramatic change of meaning of this pattern in the downstream task. So let us talk also about current problems. So as I said, so currently the most popular approach towards AI, and again, not without any reason. So there are good reasons for that. So if you look at the recent services based on deep learning models and large models, foundational models, so they do a great job. So they so they even are able to pass this formal Turing test. But there are serious problems with it, with purely connectionist approach. The main problem is that, well, first of all, life, I mean, as life shows, we live in a symbolic world. We use symbols to convey information, to store information. We use symbols everywhere. So symbolic AI exists. Symbolism in intelligence exists. And making symbols out of neural connections is still difficult. Also, the size of such models. So you know that modern AI or deep learning models are very computationally heavy. At the same time, biological brains they do a fantastic job with consuming orders of magnitude less energy. So even you probably read honeybees expose intelligent behavior in terms of understanding abstract concepts like above, below, to the left, to the right, smaller, larger. And by the way, so it's an interesting. Did you hear this news about bees being able to distinguish between this abstract concepts? So it was in. I mean, this news constantly appear in the media, and there are not that many groups working on them on this on studying honeybees, and so one of the groups are my colleagues from Melbourne. So they, I mean, they are not artificial intelligence people, but they are kind of they really studying the biological intelligence, and it's really incredible. So honeybees can master abstract visual concepts, like as I said, larger, small, different shapes, geometrical shapes, in only few trials. While I mean, neural networks, I mean, for these many trials, they are not able to learn anything, basically. And this creates really a challenge. So how the intelligent functionality is really should really be implemented. So, but again, so it is not a question. So I have to be clear here. It's not a question that we should choose one or another approach. In both approaches, so there are advantages, own advantages. So, for example, sorry. Symbolic AI. So it is founded on very solid mathematics of logic. So it can perform very interesting reasoning, and yeah, and it is successful. It used to be successful, and it is used in practical applications like expert systems, for example. The problem is that again, so it is implementation of certain intelligent functionality, but there is a problem associated with in a larger artificial intelligence concept, how the symbols appear. So, and this problem is of fundamental character. So it is called symbol grounding. So symbolists, so they assume that they simply assume that certain symbols exist. So I mean, so it's like mathematicians. So you write, you know, variables, then you construct formulas, and then so you're happy with what you have. But how to connect a symbol to a reality? So that's not evident, or it's at least it's out of question for a symbolic approach. On the other hand, so neural networks, so they don't have this problem. So they have they solve the symbol grounding problem right away because they I mean because of the way we train neural networks. So or basically the representations we inside the neural network. So by directly connecting to the phenomena that we observe. However, the problem with neural networks themselves is really constructing, you know, non-trivial constructs about knowledge. So connecting different representations together. It is also called the binding problem. So you can so that you can easily construct, for example, part-whole hierarchies. So there are some evidences, but still it is very, very hard to learn this this type of representation. So the truth is, so there is a constant debate. So how to, I mean, how to merge these approaches. And actually in this landscape, so I'm located somewhere in the middle, as I said. So I started to look at these issues purely from computational point of view on how to perform computations on low-end devices more efficiently, but ended up with the technique which is actually used in the AI concept. And this technique is called, or this theory is called vector symbolic architecture. So which is basically has connectionist nature, and at the same time, so you can craft your symbols. So you operate on the level of patterns or vectors that you generate, amongst other manually. So you can learn them, but you can also handcraft them. So and this kind of has a biological inspiration. So this this computational technique. So I think so. I have two names in this context: him and Dmitry Rashkovsky, who is here with us at LTU. And these two guys are pioneers of this computing theory. But so they use this biological inspiration. That's that neurological study shows that the number of connections involved, neural connections.
From no battery.
Sure. A number of connections used in different cognitive operations are high. So it's in the order of thousands. So, and the idea was, why not to create a computational system which work on, say, 1,000 or 10,000 bit words. So not like 32-bit words like in conventional computers, but on 1,000 words. And moreover, so these words, so they should possess pure connectionist approach. So that, meaning that the value of each position in this word cannot be interpreted by itself only. So it can only be interpreted as a whole, as a pattern. So purely connectionist. So, and this is in contrast to what is happening in, for example, conventional von Neumann computers, where we have Boolean algebra and binary words. So so we have so there the position of ones and zeros, they are all significant. So you swap one in a certain position, and then you end up with a, well, different number or different letter, so you name it. So here the idea is that you create a computational system that works on high-dimensional connectionist vectors, so which can only be interpreted all at once, not a thing. And moreover, so this gentleman over here, so he worked on a special class. So that is another observation from neurological studies, that the activations of neurons in biological brains are sparse. So we have like billions of neurons, but only a few of them, I mean, compared to the total number of neurons, participate in certain computations. So that's what I said previously, connected to this observation. So lead to computation on sparse vectors, where you have like, or when I say vectors, previously I used the term word. So basically, so you have a word like with many dimensions. Most of them are 0, only a few are 1. And then you again create a computational system that does something useful. In which way it is useful? And again, so I'm telling you this because it is kind of relevant, well, rather relevant to the content of this course. Really, as a kind of answering a challenge of what is in the middle between these two camps, connectionism and symbolism. So yes.
So I'm wondering a bit like, there's a lot of like terminology, like I don't really understand like what we're going to use it for, like what the applications are.
Mhm.
Like, so what is, are we going to use it for like logic or like, can you like tell us a bit? Or,
Sure.
Yeah.
Of course, yes. I'm coming to this, but before coming to logic, so so what I'm saying here is that there are, I mean, you look at the intelligent functionality from two ends. First, from the end of interneural communications. So that is the neural networks business, and then from the symbolic way. There is that's what I'm telling you now, is that there is a gap between these two worlds on how to. We are talking about AI, so here the AI is the key term. So it's not that we talk only about logic, or we talk about neural networks. We are talking about at this very moment we are talking about the general context of how symbols may emerge from neural interactions. And then later on, of course, these symbols will be used in more complex construct, forming logical rules. And on top of logical rules, you will apply different reasoning strategies for a given task. But just to finish this topic, so what the catch? And the catch is that if you work with this high-dimensional patterns of words, the ability of generate many symbols come for free. You see, I mean, if you think about it, it's not obvious how to generate symbolic representations. So again, so if we talk about classical logic, so you can be happy with just giving names, you know, to so say symbol S1, S2, S3, and then you can generate as many symbols as you wish. If you talk about implementation of intelligent functionality, there is no S1, S2, S3, so you need to create them. And I'm just showing you that one of possible ways of creating symbols. So if you assume that computations are high dimensional, then, and you work with the computing words of certain dimensionality, then you can randomly generate, for example, patterns. And when you do that, and you also introduce a metric, which is a measure, which is called similarity measure, which is also an essential concept in the AI. So because we all intelligent functionalities are implemented using comparing similarity between objects, how similar they are. So this needs to be implemented. So basically, on these high dimensionalities, you can randomly generate two patterns, and it can be shown mathematically that they are dissimilar. So many properties come for free. And then you can use this concept to really for symbolic computation. So you can create predicates, you can create data structures, etc., etc. So that's what this business of neurosymbolic integration is all about. So how to marry together these two AI approaches. Let me just skip a couple of slides. So if you want to know more, so I mean, you can read more on these sources. It will be available as a PDF. Let me talk about now something different again now, convergent to what actually would be the content of the course. So what I was talking about so far is the challenge of converting the perception to symbols. There can be different ways. So I commented on one possibility mainly, but this is important. So an agent is in the environment. It perceives, it samples an environment, it receives raw data, raw signal, and this raw signal needs to be converted into symbols. And then, so what is it? So now when we have symbols, what can we do with them? So let me skip this guy. So we are talking, so just to narrow down the scope, again, so having a symbolic but still AI, it means a very broad class of problems. And at the end, we are not concerned with the development of, say, super intelligence or something. So we want to extract something useful for us. What is applied part of it? And to understand that, so you need to, so we want to look at well, our digital technologies that we have. So information technologies that help to process information of different kinds towards user needs. So that's the kind of definition. So the concepts here are information, technology, and user. So what we want, as I said, in the first part of the course, we will be talking about logic. So the kind of classical way of approaching creating intelligence. In the applied part of it, we will be talking about how it can be applied on to create down-to-earth applications. So how to it can be applied to create for information processing. And the key problem here is that now in 21st century, the information and so the technology part, the users, so these terms became very ubiquitous. So I mean, they are heterogeneous. So information can be different, of different kind, different structures, etc. Technologies to process them also can be different. Robotics, search engines, etc. Users can also be different. So humans, again, humans with different characteristics, machines themselves. So how to make it all interoperable? So we are moving towards system, and we already have these solutions where different pieces of information interoperate with the help of assistive technology. So at the end, we are talking about everything as a service. But what does it mean to us? It means that we need to create an abstraction. So users need an abstraction, the information needs an abstraction, and the technology needs to understand this abstraction in order to deliver certain functionality. So we are going back to the definition of agents, but now in the context of reality in terms of information systems that we have. So we need to create abstractions, and the way to process information and enable communication between different users and different information sources. Moreover, so another keyword that what we are using, and this is the major departure from the technology that we had at the in the beginning of year 2000 or so. We are transitioning towards so-called open world assumption. So this is also crucial. Open world assumption is opposite to obviously closed world assumption, in a way that if knowledge is not present in a certain context, it doesn't mean that it is false. So, and we need to build a system that operates with in this environments, and that is challenging. And that what is kind of at the end what we are up to. So now the systems are only kind of in the beginning of their development. So we do have very good examples. So for example, ChatGPT and such. So there is a major transition. That's what we by the end of the course, what you can expect to be at least mentally prepared for. But there is still a long way to go practically there. So this open world assumption means that so you enable new kind of skill. So you are learning through asking all the time. So and you build a system that doesn't give you direct answer, but rather interactive. So you discover the information, and so you need a technology for doing that. And as if you reflect to what is existing since the last winter in terms of ChatGPT and such like that, so this is where we are going to. So the systems, they become more and more interactive and knowledge discoverable. And in this course, what we will see again, so what is the technology behind or the necessary building blocks? It's not that it's technology behind ChatGPT. This is something different. But what is needed from the point of view of knowledge representation and enabling reasoning? So that is more or less it for the introductory part. Tomorrow we start with the logic and logical agents and propositional logic.